Hey everyone, this is Algebra 2. This is Unit 7. We're talking about rational expressions. And so Lesson 7-2, we're going to talk about how to multiply and divide rational expressions. So we've already looked at kind of what is a rational expression, some of the terminology that goes along with it, right? Asymptotes, vertical asymptotes, horizontal asymptotes. We've looked at what the graphs look like and some of the features of those graphs. And today we're going to look at some of the math involved in these. So when we multiply and divide these things, so what we want to look at today is like, how can we use factoring? We spend a lot of time learning how to factor, and so we're going to apply some of those skills today, and they'll help us a lot when we go to multiply and divide these rational expressions. So there's not a lot to this. Basically, this works exactly the same as it does with just fractions, multiplying and dividing fractions. We're going to look to simplify when we can. And to do that, we're going to factor things out. So if we look at a first example here, I'm just going to do this with numbers, right? So if we were multiplying these two fractions together, right, the rules of multiplication for fractions mean we just multiply the numerators together and we multiply the denominators together. And so that's really what we're doing. We're multiplying 6 times 38 and 19 times 3. Now, we could go ahead and do that. And we'd get, some large number, 190 something, 100, 200 something, and do that here as well, and then try to simplify that. But we can make our life a whole lot easier if we can simplify this before we do the multiplication. And so that's really what we're going to emphasize today. So instead of writing 6 as 6, I'm going to write 6 as 3 times 2, right? And the same thing with 19 is a prime number. I can't factor that. 3 is a prime number, but 38 is even. And so I can also write that as 19 times 2. Now, what's the advantage here? Well, the advantage is that we can see that we can cancel some stuff out. So here I have 3 times 2 times 19 times 2, and then divided by 19 times 3. Well, 19 divided by 19 is 1. And so I can just ignore this, right? It's a 1, so it doesn't affect our multiplication. And likewise, the 3s. The 3s will cancel each other out, right? The 3 divided by 3 makes 1. And so I'm left with a 1 in the denominator. And in the numerator, I'm just left with 2 times 2. So that just gives me 4, right? So using factoring to our advantage to simplify these expressions before we multiply them can be a huge time saver. Otherwise, I would have had to, probably pull out my calculator, multiply this and see if I can, reduce that somehow. But by simplifying this and reducing beforehand, we can make that multiplication a lot easier. We're going to do the same thing over here. We're going to look at these rational expressions, right? So we've got a variable in the denominator, so they're rational expressions. And so we're going to see if they have any common factors. Are there common things that we can take out of here? And so 6, again, I can write as 3 times 2 times x, right? If I put that x in there. And then I can do the same thing with 4 here. I can write this as 2 times z, okay? And so I can look to see if there's common things here. So there's some things I can see. I can see I've got a 2 here and a 2 here that can cancel out. I've got a 2 here and a 2 here that I can cancel out. Right? Those make 1. And then I've also got a y and a y. Y divided by y is also 1. So I can take all those out. So what am I left with? I'm left with a z in the denominator and a 3 times x in the numerator. And so I get 3x over z. So using those factors to help us simplify before we multiply. And we can apply this to, to larger polynomials. The idea is still the same. We're going to see if we can factor that and see if there's something that we can cancel out. Now, the trick here, right, and the thing that a lot of people get kind of confused about is that we have to treat each one of these expressions as a whole thing. So this x plus 4 is one thing. this 7x plus 28 is one thing, right? X plus 6 is one thing. I can't just say, well, there's an x and there's an x and I can cancel those out, because that's not just x. It's 6 more than x, right? This is 4 more than x. So it's not x, and I can't cancel them out. However, I still can factor this. And so I can look at this. Well, there's no common factors there, but in here, there's a 9 that's a common factor in that expression. So here I have 9, and this is going to be x plus 6. Okay, so 9 times x plus 6. And then down here in the denominator here, I can see I've got a common factor of 7. And so I can make this 7 times x plus 4. Okay, so I'm going to rewrite those in factored form. And then I can look to see if I can simplify. And I definitely can. Here I have x plus 6 and an x plus 6. Now this is one thing. This is x plus 6. And I've got a matching thing down here. So those will cancel each other out. Those will make 1, right, when I divide those. And the same thing here, x plus 4. I got to look at the whole thing. X plus 4 divided by x plus 4 gives me 1. And so what am I left with? I'm left with 9 over 7. And this cannot be simplified, right? I can't, I can look at the factors of 9, which are 3, but 7 is prime, and so I can't really factor that down anymore. So that's how I would leave my answer there as 9 over 7. Look at another example here. So a little more complex. Here, I'm going to, again, I'm looking at this. X squared minus 25 is one thing, so I can't just cancel x squareds, right? I can't just cancel x's. I have to look at these as unique polynomials, right? So how can I rewrite this polynomial? Well, I see that's the difference of squares, and so this is, I can rewrite this as x plus 5 and x minus 5. No common factors there, no common factors there, but I can write this, I believe the factors of 45, right, that subtract to give me 4 are 9 and 5. And so I can write this as x plus 9 and x minus 5. Okay, so you're going to practice your factoring skills here. Okay, so we can go through and simplify this as well. And so I've got x minus 5 and x minus 5. Those will cancel out. Here I've got an x plus 9 and an x plus 9. Those can cancel out. And so what am I left with? I'm left with x plus 5 over 3x. And again, these x's can't cancel because this is not x. This is x plus 5. We have to treat that as one thing. So that would be my final answer.